How do we build bridges? Across the ocean. Have you ever looked at a bridge stretching across the ocean and wondered, how on earth did humans build this? I mean, the ocean isn't just a giant swimming pool. In many places, it's hundreds of meters deep. In others, it's thousands of meters deep. The average depth of the world's oceans is about 3.7 kilometers, or 2.3 miles. That's deep enough to stack more than 10 Eiffel Towers on top of each other. So if the ocean is that deep, how do engineers build massive bridges that carry thousands of cars every single day? Let's find out. The first thing many people don't realize is that most ocean bridges are not built in the deepest parts of the ocean. Engineers carefully choose locations where the water is much shallower. These are often bays, straits, or coastal areas where the seabed is easier to reach, but even then, building underwater is incredibly difficult. Before construction even begins, scientists spend months and sometimes years studying the ocean floor. They use sonar, underwater robots, and drilling equipment to create a map of what's beneath the water. They need to know whether the seabed is made of solid rock, sand, mud, or loose sediment, because the strength of the ground determines how the bridge will stand. Once they've found the perfect location, construction begins. One common method is called a cofferdam. Imagine trying to build a house, but underwater. Engineers drive giant steel walls into the seabed, creating a watertight enclosure around the construction site. Then they pump all the water out. Suddenly the workers are standing on dry ground, even though they're surrounded by the ocean. Inside this dry area, they dig deep foundations and pour massive amounts of reinforced concrete. These foundations become the legs that support the bridge. But what if the water is too deep for a cofferdam? That's when engineers use enormous steel or concrete piles. These giant columns are driven deep into the seabed using powerful hydraulic hammers. Some piles are driven dozens of meters into solid rock to make sure they can withstand waves, currents, earthquakes, and the enormous weight of the bridge above. In extremely deep water, engineers sometimes build huge concrete sections on land. These sections are floated out to sea like giant ships. Once they reach the construction site, they're carefully sunk into place and connected together with incredible precision. For bridges that allow ships to pass underneath, massive towers are built first. Steel cables are then stretched between these towers. The bridge deck is hung from these cables piece by piece until both sides meet in the middle. It's like assembling a giant puzzle in the sky. But the ocean isn't the only challenge. Engineers also have to fight powerful waves, changing tides, hurricanes, corrosion from saltwater, and even earthquakes. Every bolt, cable, and concrete pillar is designed to survive decades of punishment from nature. Some bridges are even designed to sway slightly in strong winds instead of resisting them completely. That movement actually helps keep them safe, so the next time you're driving across a bridge over the ocean, remember, beneath you could be giant concrete foundations buried deep inside the seabed, steel piles hammered into solid rock, or enormous underwater tunnels connecting different sections together. What looks like an ordinary bridge from above is actually one of the greatest engineering achievements humans have ever created. It's a combination of science, engineering, geology, and years of careful planning, and it all begins with understanding what's hidden beneath the waves. If you enjoyed learning something new today, don't forget to like the video, subscribe to the channel, and let me know in the comments.